Dealing with limits as x goes to infinity, we're still using that basic concept that the limit as x goes to infinity of 1 over x equals 0. So we're going to use this to our advantage on these problems. And the idea is we're going to change the form of this. If you were just to plug in infinity right now, sorry about all that, you would just get infinity over infinity, which is an indeterminate form. So we're going to change the form of this and use this rule to our benefit. So what are we going to divide by? Well, usually we divide by the highest power. And in this case, we see an x squared. So yeah, if you see an x squared, that looks like the highest power. But if you think about it, isn't that the same thing? It's in the square root. So if we were to square root that, it kind of reduces that power. And that would be the same thing as x. And it's actually the same thing as x. Square root of x squared is the same thing as x, as long as x is positive. Well, we don't have to worry about it in this problem because x is going way off into the positive numbers, positive infinity, right? So that doesn't really affect this. So we can use this for the outside. So we're going to use this one for the outside. Or not the outside, the inside. This is for the outside. And this one's going to be for the inside. So let's go ahead and set it up just like we did in the previous section. So this is going to be the limit as x goes to infinity. And I'm going to divide everything. So I'll divide the 4x plus 1. I'm going to divide those by x because that's on the outside. And then on the inside of the square root, the 4x squared plus 4x, I'm going to divide those by x squared. So basically, if it's on the inside, we're going to divide by x squared. And from there, we'll simplify. So 4x squared over x squared is going to be 4, thinking inside the square root right now, plus 4 over x over 4x over x, the x cancels, and then plus 1 over x. And then we have that's equivalent to the limit as x goes to infinity of that. You need to not forget that limit sign. Sometimes I do. All right, now applying this idea. 1 over x as x goes to infinity. 4 over infinity would be 0. 1 over infinity would be 0. So those 0 out, and we're left with the square root of 4 over 4. So as we apply this x going to infinity, this will 0 out, that will 0 out. We're left with square root of 4 over 4, which is 2 over 4, which is 1/2. And this problem here is very, very similar. You could work that out if you want to. And that answer, I believe, is just going to get you 3. Let's go ahead and take a look at this one. So this is going to be a little bit different. So one thing I want to bring up is notice this is that x is going to negative infinity. So let's set it up. We have x to the 5th and x to the 10th. So x to the 5th on the outside, and it's equal to the square root of x to the 10. Now let's think about this real quick. If we think about this statement right here, what if x was negative? Which it is in this case, because x is going to negative infinity, so we're dealing with negative numbers. So what if I were to plug in, let's just say, for example, a negative 2. And over here, we'd plug it into that x as well. Let's see if it's truly equal. So negative 2 to the 5th is going to be negative 32. And then over here, 2 to the 10th, square root that is just going to give us also just a positive 32 instead, though, because anything to the 10th power is going to become positive, and we can't even square root a negative number. So we know for sure this right-hand side is going to be positive. Well, here's the problem. The problem is that when we plug in a negative number on this left-hand side, it gave us a negative, and when we plug in a negative number on the right-hand side, it gave us a positive. Well, these are supposed to be equivalent, and they're not equivalent, and that's why I specified over here it would be equivalent. Notice this is an odd power. This would be equivalent if x is positive, but over here, x is not positive. X is going to negative infinity, so our x is negative. So we run into this issue right now. So that's not truly equivalent. What we could say, though, so it's not equivalent if x is negative. What we could say, though, is that x to the 5th equals negative square root of x to the 10. And this will work because now if we plug in the negative 2, that negative is going to do the adjustment. So we kind of have this split here. This will give us negative 32. This will give us negative 32. And so this is going to help us. This is going to help make that equivalent. Now I want to go ahead and use this. Before I do, let's talk about this a little bit more. X to the 5th. Let's just say, for example, you had x squared. That's the same thing as square root of x to the 4th. Because it's an even power, we wouldn't have to worry about the whole negative thing, because no matter what I plug in here is positive, no matter what I plug in here is positive. These will be equivalent for all real numbers. But the reason why we had to do this is if you have an odd power and x is going to negative infinity, that particular case where you have an odd power and x going to negative infinity, that's the one time that we're going to have to put that negative in front of the square root, because that's the only way this could be equivalent for negative values of x. So let's go ahead and use this. It's only going to make one little difference. It actually gives you the complete opposite answer, but that's the difference, is there's just going to be a negative sign in this. So we're going to have x to the 5th plus 4x squared all over square root of x to the 10 plus 8x to the 7th. So I'm going to divide this by x to the 5th, this by x to the 5th, and then the bottom here is going to get divided by square root of x to the 10, but with that negative in front. So what's going to happen is this negative right here is just going to get brought out to the front of everything. We'll put it in the front of that fraction sign. Simplify the top as 1 plus 4 over x to the 3rd. Then inside the square root, we'll divide each thing by x to the 10. So really that only difference is that negative that came out to the front. Alright, so now let's go ahead and apply that limit. So we know that this will go to 0. This will go to 0, and this is just equal to 1. X to the 10 over x to the 10 is just 1. So we'll get negative 1 over the square root of 1, which is just negative 1. So let's just take a quick look at this. This one, if we have x going to negative infinity, so we've got to pay attention to that, and then x is on the outside square root of x squared. Is this an odd power? Yes, it's x to the 1. So we're going to have to write this with a negative in front. So we're using negative square root of x squared if our x is negative in order to adjust, to do that same adjustment that we talked about before.